Hello there, welcome to TutoriMane. Let's continue the series for relations and functions, and we were in exercise 1.1, problem number 7. So, it says show that the relation R in the set A of all the books in the library of a college given by R, x, y, where x and y have the same number of pages is an equivalence relation. I hope you remember what equivalence means. It means the relation has to satisfy all the three conditions, that is reflexive, symmetric, and transitive. So let's see. So for reflexive, it has to be in the form of x, x means what? X and x have the same number of pages. X and x, it's the same book, right? So it does have the same number of pages. It is very direct. It is reflexive. So let's see. If it is symmetric, it has to be in the form of x and y and x means x and y have the same number of pages, which means y and x have the same number of pages. It is very direct again. So it is symmetric. Let's see if it is transitive. It means x is equal to y is equal to z, and x is equal to z, which is pretty obvious. So it is transitive. So moving on, let's come to the 8th one. It says, show that the relation R in the set A from 1 to 5 given by R is equal to mod of A minus B is even. Remember this. It's a unique condition, right? It's something different. It's an equivalence relation. And all the elements of the set 2, 4 are related to each other. But no element of the set 1, 3, 5 are related to the set 2 and 4. Let's see. Don't get confused. We'll just solve the first part first. So for reflexive, you know it has to be in the form of a, right? So a minus a, mod of a minus a is 0, right? Anything minus the same thing is 0. 0 is an even number, so it is reflexive. Let's see for symmetric. It has to be in the form of a, b and b, a. And that means what? A minus b is even. Then b minus a is also even, right? Don't worry about the negative sign because we have modulus. So it is symmetric. You can take any example. 2 minus 4 and 4 minus 2. Mod is even. So let's see for transitive. So it has to be in the form of a, b, b, c, and a, c. Don't you think it's pretty direct if you have... Okay, so don't you think if a minus b and b minus c is even, then a minus c is even? I'll just show you now why. Because if you add any two even numbers, you will get even numbers. For example, 2 plus 4 will be 6. Even if you add any two odd numbers, you get even number. Let's not go to that. So let's stick to this. So it is transitive. And we had a second part, right? Let's see what they are asking. So they said the set 1, 3, 5 must be related to each other. 2, 4 must be related to each other, but no element of 1, 3, 5 are related to 2, 4. Here, in what way are they telling it must be related? Remember the condition mod of A minus B must be even. So here, your element A and element B are coming from the same set 1, 3, 5. So if it is coming from the same set, so if you take 1, 3, you get 2, or 3, 5, you get 2, which is even, right? So it is related to each other. Let's go for the set 2 and 4. So if you take 2 and 4, 2 minus 4 is also 2, 4 minus 2 is also 2, which is even. So that is also related to itself. But they're telling no element of 1, 3, 5 are related to 2, 4. So this time you take one of your element A from one set, B from the other set. So if you take 1 minus 2, you get 1. 5 minus 4 is 1. 3 minus 2 is 1. It's always odd. It's not even. So as they're telling, no element of 1, 3, 5 are related to 2 and 4. So next question is very simple. So the condition given is x is from 0 to 12, and there are two very similar conditions which are very simple. The solution will be given in the end. You can refer to it. So 10th one, give an example of the relation which is symmetric but neither reflexive nor transitive. Okay, this is interesting. Until now we solve problems where they have given the condition and we tell if it is symmetric or reflexive or transitive. This time they are giving the condition and they are telling us to write any relation. You can take this as two ways, okay? So if you want, you can write simple relations like we wrote, like 1, 1, 1, 2, and which is very direct. You can write it like that. But if you are aware of any condition which satisfies what they are telling, you can definitely go for it. So I will show you both the types, okay? Let's see. For this, let's write a simple one. Let's take the relation 1, 2 and 2, 1. It is symmetric, right? That is what they're asking. They're telling it has to be symmetric but neither reflexive nor transitive. So done. That's all. That is the problem. You don't have anything in 1, 1, so it's not reflexive. You do have 1, 2, 2 and 1, which is symmetric. And obviously it's not transitive. So let's go to the second one. It has to be transitive but neither reflexive nor symmetric. So now, do you remember we had previously solved a problem whose condition was A must be less than B. So if you see for this, if you take any values, A must be less than A. If you take it for reflexive, that means A must be less than A, which is not right logically. A is equal to A, right? So it is not reflexive, just like they're asking. So let's check for symmetric. It must be in the form of A comma B and B comma A, which means what? If A is only less than B, then B is greater than A. It's logically not possible, so it's not symmetric. But look, here it is going to be transitive. If you take the example like I've shown, 1 is less than 2, 2 is less than 3, and obviously 1 is still less than 3, so it is transitive. So these are the two kinds of example you can give, and there are 3 more questions like this which I have given you to solve. Do try it on your own, and the answers will be given in the end, just like always. So let's move on to the next one. So the 11th one, it says show that the relation R in the set A of points in the plane given by R is equal to PQ. Distance from the point P from the origin is same as the distance of the point Q from the origin is an equivalence relation. So let's see. So for reflexive, we know it has to be in the form of P comma P, right? That means what? P, the distance P from the origin is same as the distance P from the origin. First of all, it's the same point, so from the origin it does have the same distance. Imagine a circle, okay? Since they're telling origin, we have to imagine a circle. So it is reflexive. Let's move on. For symmetric, we know it has to be in the form of P comma Q and Q comma P. That means what? P is equal to Q and obviously Q is equal to P, so it is symmetric. Let's see for transitive. So if P is equal to Q and Q is equal to S. Why I have taken S here is because we are already using the representation of the letter R for relation. So don't get confused. That's why I've used S. So like I was telling, if P is equal to Q and Q is equal to S, then obviously P is equal to S. It is very direct. Like every single problem in this exercise, it's very simple. So it is transitive. But there was a second part of the question which I asked, further show that the set of all points related to the point P that is not equal to 0, 0. That means what? It's the origin, right? And it's the circle passing through P with origin as center. Okay, so don't get confused. What are they telling? Show that the set of all points related to P is the circle passing through P with origin as center. Means what? They're telling, imagine a circle and there are other points that are related to P, but show that these points are coming from origin of the circle and show that the origin is at the center. So let's see what they're trying to ask. So just imagine a circle with origin 0, 0 and a point P on the circumference of the circle. So they are telling it has to be a set of all points related to point P. Related means what here? Again, we have to go back to the condition given in the problem. The distance of P from the origin must be same as the distance of that point we are referring to. So if the distance has to be same, it has to be on the circumference, right? And it is with respect to origin. And only if origin is at the center of the circle, only then the distance will be same, right? You can imagine like the radius of the circle. That means what? Origin is obviously at the center. It is a very simple explanation. You just have to get it. Okay, let's move on to the 12th one. Show that the relation R defined in the set A of all triangles as R, T1, T2, T1 is similar to T2 is an equivalence relation. Okay, we've come to triangles. So for it to be reflexive, it has to be in the form of A, A means what? Two triangles that are similar to each other. Every triangle is similar to itself. Don't forget that. So it is reflexive. Let's see for symmetric. It must be in the form of A, B and B, A means what? Triangle A and triangle B are similar. That means B and A are similar. So it is symmetric. Let's go for transitive. A must be equal to B and B must be equal to C. And obviously A is equal to C, right? So you can see here, if triangle A and B are similar and B and C are similar, basically A and C are also similar. So it is transitive. There's a second part to this question which says consider three angles triangle T1 with sides 3, 4, 5, T2 with sides 5, 12, 13 and T3 with 6, 8 and 10. Which triangles among T1, T2 and T3 are related? So again, see, they've asked which triangles are related. Here related in what way? Since the question said the triangles must be similar to each other. And similar in what way? Here, since they've given us the sides, we have to work with the sides. So sides in what way? We have to check their ratios. Okay, let's see for triangle T1 and T2 first. So let's compare the sides. So if you compare 3, 4, 5 and 5, 12, 13, you don't get equal ratios. So triangle T1 and T2 are not similar. Let's move on. Let's check for T1 and T3. That is 3, 4, 5 and 6, 8, 10. So, okay, we are getting a ratio of half from all the three sides. That means T1 and T3 are similar triangles. So the problem 13th and 14th are very similar to the previous problems here. In the 13th one, they're talking with respect to P1 and P2 having same number of sides, and in the 14th one with respect to parallel lines. So please do try it on your own. Let R be the relation in the set 1, 2, 3, 4 given by R is equal to 1, 2, 2, 2, 1, 1, 4, 4, 1, 3, 3, 3, 3, 2. Okay, it's a long relation. Don't worry about that. Choose the correct answer. Okay, this is a multiple choice question. So let's see. R is reflexive and symmetric but not transitive. Let's see the first option itself. They're telling R is reflexive. Is it reflexive? Yes, we do have 1, 1, 2, 2. Yes. Is it symmetric? We have, let's see, we have 1, 2. Do we have 2, 1? No, and it is not present for any other number. Let's move on to option B. So R is reflexive. Yes, we just saw it's reflexive. Let's see if it is transitive. So, for example, if you go to the number 1, 3, you have 1, 3 and you have 3, 2. That means what? You should have 1, 2, right? Which you do have. So don't you think it's transitive? Also, you do have one more transitive set here. For example, you have 1, 2 and you have 2, 2. That means you should also have 1, 2, which you do already have, right? So it is option B. So option A is wrong, option B is right. So obviously the next two are wrong. Let's move on. 16th one, let R be the relation in the set N given by R, A, B. A is equal to B minus 2, where B must be greater than 6. Okay, let's see the options we have. See, they have already given us a condition where B must be B must be greater than 6. So, let's see if B is greater than 6. In the first option A is 4, which is already less than 6. So, let's just leave option A. Let's come to option B, where B, C, D have all the B's greater than 6. So let's substitute and check. So for example, if you substitute B as 8 in that, what happens? 8 minus 2 will be 6, right? Which is option C actually. We don't get 3, but here also B is 8 and A is 6, which is the right option. So C is the right option. So here are the solutions. You can pause the video and refer to it. Thank you for watching with TutoriMane, and I'm going to continue the problems and other concepts in the coming videos. Thank you.